Welcome to another episode of Arm Viewpoints, the podcast where we bring you technology insights at the intersection of AI and human imagination. I'm Brian Fuller, editor-in-chief at Arm, and today I'm joined by someone who truly needs no introduction in the tech industry, Bob O'Donnell, president and founder of Technalysis Research. Bob has spent more than 2 decades analyzing the technology landscape, from his early days in tech publishing to nearly 15 years at IDC, and now leading his own independent research firm. In this episode, we dig into Bob's latest research on one of the most important shifts happening in AI today, the rise of hybrid AI. We explore what hybrid AI really means in practice, why enterprises are starting to rethink cloud-only strategies, what's driving the so-called great AI repatriation, distributed AI architectures, AI PCs, agentic workflows, and what CIOs and IT leaders should be doing now to prepare for a more decentralized, heterogeneous AI future. And much, much more. It's a wide-ranging conversation that cuts through the hype and gets to the real architectural, economic, and strategic decisions organizations face as AI scales from the cloud to the client and everywhere in between. So, the man, the myth, the legend, Bob O'Donnell. Thanks for joining us. How are you, Bob?
I'm good, Brian. Thank you so much for having me. It's great to be here.
You and I have known each other for more years than we're going to admit on this podcast. But for those people who might not be familiar with you, give us a little bit about your background, your work at Technalysis, that sort of stuff.
Bob O'Donnell, president of Technalysis Research, and I've been a tech industry analyst for a little over 25 years. Started clearly as a young child. But I started, prior to that, I was in computer publishing. So I was at some of the Mac publications, PC publications, online publications, the era of the beginning of online digital publishing for computer mags, and then started working at IDC. And I was at IDC for about 14 and a half years, and then started my own firm, which is Technalysis Research, and I'm now in year 13 of that, I'm happy to say.
Interesting that you and I both share that publishing background, and there were points in that particular era of my career where I thought about going the analyst route. Why did you choose that path?
Yeah, I know. It's a good question. So I actually had a buddy that I used to work with at one of the publications that I was at. I think he and I worked together when we were at Mac Week. And he went to Forrester, I believe it was at the time. And I ran into him at an event or something. And I said, hey, how is it? And he says, oh, it's great, and because you really get to dive deeper into the products and the strategy and everything else. And I'm like, oh, that's for me. That's the kind of thing that I want to do. And happy to say, it's one of those jobs where, sometimes right away, either to the positive or to the negative with certain jobs. And this is one of those things where it just clicked right away. And I was like, wow, I think I found my home. I think I know what I want to finally be when I grow up.
Yeah.
And so that's how it happened. And since then, it's been a great run.
Indeed, it has. Then you went out on your own after IDC, which to some people would be a little nerve-wracking, but you've knocked it out of the park. Talk a little bit about that transition.
Yeah, no. So, I had reached a point at IDC. I was doing well. I had a good title and everything else, but I also kind of saw that I had hit a bit of a ceiling in terms of where I was going to be able to go. And my interest had broadened. I wanted to get into, at IDC, I ran all the device research. So PCs, smartphones, had just started the wearable research. And I love all that stuff and continues to be a huge part of what I do. But I also saw a lot of other opportunities out there. And I wanted to really stretch. And one of the challenges when you're at a big firm is you tend to be in a very deep but clearly defined stovepipe, meaning, hey, you can talk about this, but don't talk about that because that's somebody else's swim lane. And I was like, you know what? That's not what I want to do. I want to broaden myself out. And, a lot of the business of analyst relations is really based on relationships that you have with folks, senior execs at a lot of companies, as well as the folks who run these AR programs. And I felt like, I think people are willing to talk to Bob, not just Bob from IDC. And I'm like, if I'm ever going to do it in my life, now's the time. But I felt like I had the opportunity, and it's been fantastic.
And your insights have always been fantastic, always been ahead of the curve. And speaking of insights, you recently published a report on hybrid AI. Tell us a little bit about that. First of all, how do you define hybrid AI, and what did you learn from how enterprises interpret that term?
So one of the things that I determined was going to be important when I started Technalysis was to do my own independent research. There's a lot of smaller independent analysts, but not a lot of them do kind of in-depth research. And I always felt that would be a calling card for me to be able to distinguish myself. And it's proven to be the case. And so every year I tackle a topic or two that I think is going to be relevant to a lot of people in the industry. And obviously AI and generative AI has been a huge factor, and I've looked at that. But in particular this year, what I wanted to look at was this idea of hybrid AI. And by hybrid AI, I'm referring to the concept similar to hybrid cloud, where you leverage public cloud and then you have your local private cloud. And then with AI, it was a similar kind of thing where you're doing AI workloads in the cloud. Some companies are starting to do them within their own private cloud enterprise. And then, of course, on the client. That's the third tier of this hybrid AI infrastructure or idea, I guess. And that's really what I wanted to dig into was how were companies thinking about trying to do AI? Because what we've seen from, pretty much early on with hybrid AI, or excuse me, with generative AI overall, you get the best results when it's the tools, the models are customized to your own data. So if I'm a big organization, I want to be able to leverage all my corporate data, but I don't necessarily want to share it in the cloud. And so for a lot of different reasons, it just seemed logical to see more of this workload being divided. And then, of course, the third big piece is we started to see this notion of an AI PC and AI-enhanced smartphones as well. So the compute capabilities came along at the right time. So we saw the development of these big transformer models, which originally, of course, had to run in the cloud. But then we recognized, hey, they could be done, small language models and other things could be run locally on device. And then you realize, hey, wait a minute, I can leverage some of this stuff within my own data center as well as the public cloud. And that's how the pieces started to fall into place for hybrid AI. And it's fascinating, I have to tell you, because at CES, I was at all the major tech keynotes, which ironically were from all chip companies, which is kind of crazy. Well, except for Lenovo had a big one, of course. But every single company at that event used the phrase hybrid AI. It was clearly, the talk of the big, tech leaders in terms of where they're headed because they see this happening, right? A lot of people initially got excited about doing these workloads in the cloud because that's where the tools were. ChatGPT obviously is the first one. Then we've seen Gemini and Anthropic and all the other ones that have become a big deal. But we've also, again, seen more stuff start to happen locally. And now that is really in full momentum. And the implications of that is what I really wanted to get into. I know this is a long answer to a short question, but it was understanding those pieces and then trying to say, what does this mean if I'm an organization and I need to figure out how I want to create an AI strategy that's going to leverage all the tools that are available to me and leverage my own data in a way that I am comfortable with.
You always have expectations when you field a survey, right? What jumped out at you and surprised you?
There were a couple of things. One of them was how willing organizations were to start to bring some of these workloads from the cloud onto their own premises. And, it's been helped by a couple of things. We've got, Jensen Huang of NVIDIA talking about the enterprise AI factory, right? He talked about AI factories, and enterprise AI factory, of course, is doing this on your own. Basically buying GPU equipped servers for your own organization or a private cloud that you're using of some sort, Colo Center, for example. So that's been a big thing, but I was surprised at how willing companies were to make those investments because those are big investments and the skill sets for that are a big issue because not a lot of people have those skill sets. The other thing that really surprised me is the fact that we saw a lot of interest in AI PCs from a strategy perspective. Now, look, the reality is AI PCs, we thought initially were going to really become this huge driving factor. They've done okay, but they haven't actually taken the world by storm just yet, in part because we haven't seen a whole lot of AI applications running on PCs. We've seen some models, but not a lot of the applications. Anyway, but even despite that concern, the number of people who said they were strategically important for the future was staggering. So that really surprised me as well, because again, sales haven't really translated quite yet, but it gives me hope that we will see those sales over the next year or two.
You used a phrase in the report that I really love, the great AI repatriation.
Yes.
Define that and tell us a bit about what's driving organizations to pull AI workloads out of the public cloud.
10 plus years ago, momentum seemed to be towards we're going to put everything in the cloud. We're going to close all the local data centers. And that's just the way it's going to be, right? It's kind of almost back to the mainframe terminal model of way back when. But then a lot of organizations realized, A, the costs were super high to do that. There were a number of other challenges with regard to that. So we've seen some companies bring some of these workloads back. And with AI workloads in particular, we're starting to see this. And it's for a couple of different reasons. One of course, is cost. And in fact, the number one reason why companies said they're starting to move some of these AI workloads back is because the costs involved. The other thing is security and control of the data. What we've learned with AI is it's really important to have your own data be used to fine-tune the models. Initially, we thought companies were going to build their own models. We found that really doesn't make much sense. But what you can do is fine-tune existing models and then leverage your own data. And that becomes a kind of classic case of what we call data gravity, where you want to do the computing where the data lives. And the most precious data that most organizations have is still behind their own firewall. That's the stuff that's the most important stuff, which in turn becomes the most valuable stuff when you want to fine-tune or train an AI model and then build applications around that. So it's that data gravity, the costs and what have you that have really given companies this sense of, hey, this is what we need to do. We've also seen, again, the rise of these GPU-equipped servers from all the big, server guys, the Dells, the HPEs, the Lenovo's, Supermicros, all Cisco's. All these guys are building these servers that companies are realizing, hey, we can put them in place, run some of our workloads here, and that's what allows that repatriation. Because now the things they used to only be able to do in the cloud, they've created or are in the process of creating the infrastructure to do that. And that's where that notion of the great AI repatriation comes from, is that the beginnings of that movement.
So you've sort of preempted my next question a little bit, which is we're seeing a balanced distribution across cloud, private data centers, and the edge. What does a fully realized three-way hybrid architecture actually look like in practice?
It's exactly what you described, Brian. And look, so I think we're going to see every variation known to mankind. And what do I mean by that is we are certainly going to see some AI workloads that stay in the cloud because it just makes sense. The tools are there. There's not that much data egress charges for moving data back and forth, because one of the reasons for the repatriation too is you're tending to move a ton of data. When you're training and fine-tuning these models, that's a lot of data movement. And a lot of times there are very expensive charges to do that back and forth. So companies are realizing that they can do some of that stuff on their own, but they're going to do some in the cloud. And then we're just seeing the beginnings of running some of this on the device. So back to what I was starting to say is some workloads are going to stay in their own environment. Some will just be in the cloud. Some will just be in the enterprise. Some will just be on the client. But we're starting to see companies go, hey, maybe I can start to do some of this work on a client, but then tap into the public cloud when I need to, or tap into my own enterprise. So I'll give you an example of where I think we're going to see happening here in 2026. This notion of an AI browser. At first, it was like, oh, wow, what's the big deal? I launch a browser, and instead of going to google.com, it goes to chatgpt.com or goes to perplexity.com. It doesn't seem that big of a deal. But what companies are starting to do, these browser companies are saying, hey, we can start to build models, small language models, and orchestration engines that come along with the browser. So when I download that browser, and it's always being updated because we always know browser updates happen seems like a couple times a day. That means the model's being updated, but this orchestration piece of it means You could have something where you type in a query or some kind of request to the local engine, and it says, oh, actually, I can answer that one on my own, not send it to the cloud at all. Or it can say, I can do a portion of this here on the device, but another part I'm going to have to send to the public cloud because I simply don't have access to that. And just that ability to split those workloads could have a huge impact on terms of the power requirements, right? Because one of the things we've been hearing about as well that's driving hybrid AI is the fact that we can't necessarily count on these big data centers having access to all the electrical power that they need. So another reason why companies are thinking about this is like, hey, if I have my own private GPU server farm, then and I can control the power to that, then I at least know I've got that. But longer term, it also means in terms of the electricity usage. So imagine that scenario, that AI browser, like I said, between the client and the public cloud. You could start to write custom applications that do the same thing, but it's between a client device and the enterprise data center, because maybe all your custom CRM data is, within the walls of the data center, but you've got a local tool on your client that does some of it, then hits the data center. And then eventually, of course, you could do a three-way distribution where some applications can do some stuff in the public cloud, do some stuff locally, and then do some stuff in the enterprise. So we're building the tools now and the standards, most importantly, to enable this. So things like MCP, which is called Model Context Protocol. It's a standard by which you can distribute AI workloads and hit various AI servers, and the physical location of the server isn't really relevant anymore. And so that's enabling this notion of a distributed heterogeneous architecture where, again, you can do the different compute elements in different areas, depending perhaps where the data lives, classic data gravity, and or where the most appropriate compute requirements are. And eventually it's going to be, and where is their power? So all of these factors kind of come into play. And that's why I think we're starting to see so much momentum behind the overall concept of hybrid AI. And that's how these workloads are starting to be built.
Are you seeing yet any patterns in workload placement?
No, I mean, it's still early days, to be clear, right? So I think we're seeing a little bit of, we're certainly seeing a little bit of the client and cloud combinations. I think companies are still building their own custom applications. They're going to leverage client and the local data center. But I think I think we're going to see a lot more of that. I mean, look, you could argue, if you think about it, what Apple's, they call their private compute is basically a hybrid AI model because they recognize that there's a certain amount of AI they could do on the client, but the other part they were going to have to go out to the cloud for. Now, in their case, it was a walled garden sort of cloud environment, but essentially that's a hybrid AI model as well. So we're going to see other variations like that are starting to be built. But in terms of the exact way it's going to be split up, I think it's still a little early to tell. But like I said, I fully expect to see different variations of all three or any two or three, are going to be created.
So in your report, 60% of organizations are extending AI to the edge, right? We've talked about that distribution. What's the primary driver? Is it latency? Is it privacy, cost, user experience?
Not every workload is ideally suited for every environment. Like some workloads clearly are going to be better on the edge. And so they're the easy ones to knock off are things where latency is an issue or that's, for example, in a manufacturing environment where the sensors and the equipment are there, you're going to want to run those AI workloads locally because just the time to go back and forth to the cloud, even though it's not huge amount, can make a real difference in certain types of applications. So certainly latency is an issue, overall response time in terms of the speediness of the calculations. The amount of data that has to be transferred is also a factor in all of this. So, in the study, one of the things I asked about is, hey, which workloads are you running in which environments? And I have a breakdown of that with a fair amount of detail by company size and by industry and a whole bunch of stuff. And so things like robotics, manufacturing, automation, those kinds of things, computer vision, all of those kinds of things have typically been things you've thought about running on the edge. And no surprise, now that they're being AI enhanced or AI equipped, those things are running in edge environments. And I think over time, we're going to see more and more of those. But right now, it's kind of things that you would normally expect are running on the edge. But one of the biggest takeaways, I think, from the entire study was the fact that over the course of the next couple of years, people expect this split where it's primarily in the cloud now, of course, not a surprise, that, within a couple of years, they expect it to be much more of a almost equal split, still a little bit more in the cloud, but significantly more on the client and then in the enterprise data center.
So earlier you mentioned AI PCs. Going forward, what kinds of applications or experiences will these devices enable that we're not really seeing yet? How will they differ from the traditional notion of a PC?
Yeah, no, it's a great question. And I think the big thing that's going to happen locally is agents. We've been hearing about agentic AI, right? So it just makes sense to have an agent that's doing something on your behalf run on your device. And in fact, I think that's going to be the biggest application for AI PCs for the next couple of years. We'll see other things as well, but I think that's going to be really important. Is this the idea of an agent that's doing things on your behalf? Now, again, many times those agents will request data from the public cloud to address a certain query, like if you say, hey, book me a flight to wherever, right? So it's doing a little bit of its own thing, but it's basically then it's going to go to the websites of the airlines and other things that it knows that you like to use, and it's going to compile that and put it together, and it's going to store it on your calendar. So you're going to see, that's a classic example of an agentic workflow where you've got some compute running on the device, and then it's leveraging some things from the public cloud. The other thing might be, again, maybe I have to book a meeting. And then in that case, if I'm in a big organization where I have to, specify I want this meeting room at this time, it's going to leverage that data is probably stored within the local enterprise data center. It might be in the cloud, but again, I've got an agentic workflow I've started on the client device and then runs in the enterprise data centers. I think it's going to be, a lot of agentic things that happen. And then slowly but surely, we are going to start to see more other general purpose applications run on AI PCs because a couple of different things are happening. Number one, of course, we've seen more AI compute, NPUs. I do have a few comments I'll mention on NPUs in just a sec, but NPUs have been a part of this. We're seeing a lot more usage of GPUs. And the fact of the matter is that CPUs still play a really critical role in doing all of these kind of workloads. So it's, we talk about a distributed environment across public, private, and client device, but there's also a distributed compute environment within the SoC between the CPU, the GPU, and the NPU. So you've also got that going on. So that's going to help drive some more things. Another huge factor is, especially in the Windows world, there was not a single standard to be able to leverage all the various NPU architectures. Because one little niggly technical detail most people didn't realize is that when Intel did an NPU, and then AMD did an NPU, and Qualcomm did an NPU, they were all completely different, which means I'm a software developer and I want to write an application that leverages the NPU.
Yep.
I had to write 3 different versions of that NPU function for each architecture. Well, obviously that is not sustainable. So finally, Microsoft kind of dealt with the issue, and they just released late last fall something called Windows ML. And Windows ML becomes this sort of abstraction layer that lets a general purpose developer write something, and then it interprets and takes care of the translation to the various NPU architectures. That was absolutely essential before we could start to see, general purpose PC AI application. And, it takes developers a couple of months, to build tools that leverage that. So that's why starting here in 26, we're going to see more of those kinds of applications. So I think that's going to be a big piece of it. The other thing is we're also seeing much more clever quantization and model distillation techniques, whereby you can take these huge models and reduce them down to a size that can actually fit and run on a PC. And again, then you throw in things like MCP and the ability to do some work locally and some in the cloud in a standardized way. I don't have to create a special means to communicate with other servers. All of those pieces kind of lay the groundwork for the ability to build these AI PC applications.
So what's the single most important takeaway you want CIOs and IT leaders to draw from the report?
The single biggest thing is to start planning out a hybrid architecture and figuring out how you create those distributed apps. I mean, look, it's not easy to do, right? I mean, I'm saying that there are some tools, there are some, but there's still a lot of holes to be filled. And there's security folks who've said, hey, current versions of MCP have some big, security holes that have to be addressed. So there are issues that have to be overcome, but you've got to start planning. These things don't happen overnight. Start thinking about how you can build the infrastructure that you need. By the way, all of a sudden, networking and connectivity become way more important. I've argued, in fact, that in a case of a PC, a 5G modem could be just as important as any other element in the PC, because if I am in a hybrid computing environment and I want to be able to leverage my AI tools regardless of where I am or regardless of what connectivity I have, I want to have an always on connection. So especially if I travel around as I do and a lot of folks do, you need to make sure that connectivity is there, because if I'm running something that can do some local compute but then needs to go to the cloud for other elements, I want that connection to be always there. So I think it's going to lead to a renaissance of interest in cellular equipped modems on PCs. So I do think that's going to be important. So that's something for organizations to think about. Then again, what level of commitment do they want to make to these GPU equipped servers? I mean, these are not inexpensive purchases. These are 6-7-figure types of purchases that these companies have to commit to. That's a big deal. And then getting the expertise in-house. One of the biggest challenges that companies said is, hey, we don't have the skill sets yet. Now, to be fair, a lot of these AI skill sets are brand new for everybody. So there's just a lot of education that has to happen. But that's, again, part of the planning process. But bottom line is, it's definitely a world where there's opportunity to leverage the cloud for what it's best at, leverage the enterprise data center for what it's best at, leverage the client for what it's best at, and then figure ways that those three different elements can work together. So let me put those elements in place, and then let me get my, in-house custom application developers working on ways to leverage these pieces. And then, of course, whatever third-party tools become available, perhaps leverage those as well. So those are all the pieces I think companies need to think about, and IT managers and C-level execs, in terms of figuring out a strategy to create this capabilities to do hybrid AI.
A lot of complexity there, but also a lot of promise, Bob. Where can listeners access the report?
They can find it on my website. It's on the homepage. There is a free version at technalysisresearch.com, TECHNALYS, and then the word research.com. Actually, you can even go to justtechnalysis.com. It'll redirect you. And right there on the homepage, you'll see hybrid AI. There's a free version of a summary, the first 20 or so slides that cover all these key highlights.
Let's wrap up with a little off-topic lightning round. 4 quick questions. Keep the answer 1 or 2 words. 1 book that changed your life.
Zen and the Art of Motorcycle Maintenance.
Oh, that's a good one. William Least Heatmoon, I think.
Can't remember the author.
All right. Last meal.
Oh, it's got to be a big, juicy ribeye, scalloped potatoes, maybe some Brussels sprouts, big, beautiful Cabernet. I'm good.
Favorite can't live without technology.
Whew. I guess I would say my PC. I mean, it's just that's what I am, and who, that's the device that I mean, I love my smartphone too, but I still, I'm old school. I still kind of go back to that PC. That's where I like to get stuff done.
Favorite thing to do when you're not divining the future of technology?
Playing music, unquestionably. I've got a band, and that's what I love to do.
Rock on, Bob. What a long, strange trip it's been.
Indeed. Indeed.
Bob O'Donnell, thank you very much. You've been very generous with your time. We appreciate it. So thank you.
Thank you, Brian. Appreciate it.